Hello everyone. In this video we will see is there any proof Tesla actually transmitted energy 26 miles. This video is brought to you by Question Response, the channel where you will find the answer to everything. Today Steve Baker, Petra Blackstone, Mike and Andrew McGregor are going to present their answers to us. Let's see Steve Baker's first answer.
No, and, to the contrary, the techniques he was using could never have worked. As a general rule, anything Nikola Tesla did in the first third of his career was genius. Anything he did in the middle third is exaggerated and lied about and is completely untrustworthy. Anything he did in the last third was a descent into madness and must be ignored. He seems to have run out of good ideas and workable solutions after that first third, and he was losing investors and desperate to come up with breakthroughs, so he started to claim successes that he didn't achieve in order to pull in more investment money to keep his lab running, and for a while, that worked. But eventually, he did start to lose his mind, and he survived by living in hotels and skipping out when it was time to pay. Ultimately, he was certifiably insane. The long-distance energy transmission work was in the second phase.
We can continue with Petra Blackstone's answer.
There really isn't any evidence supporting it, but there is plenty against it. From Debunking Some Common Myths. 12. Tesla lit up 200 bulbs, 26 miles from his transmitter. This claim was in the O'Neill biography of Tesla. No other evidence. But wait a minute. Was Tesla bragging about sending kilowatts of wireless power over that distance? Or might he have been bragging about managing to transmit actual genuine signals over that distance? In 1899 neither one had been done, so it could have been the second one. That 26 miles. Was it roughly the distance from his lab to Pikes Peak? If so, here's a bunch of pure speculation below. Why would you decide to set up a huge bank of bulbs approximately 30 miles away, for radio experiments? Not Tesla. It's obvious. It's for instantly testing distant receiver equipment. Yes, I could pay a telegraph company to string 40 km of wires and poles out to a distant receiver shack. Or I could have my assistants riding horseback, back and forth daily, delivering timed lab notebook entries of the receiver readings. Or they could be signaling me at the main lab with large sun mirrors. Or, I could set up a huge cluster of battery-operated light bulbs, then view them through a telescope. High watts, large battery bank needed, to be seen 30 miles away in daylight. Rats, that doesn't work. The problem is that anything more distant than 15 km is hidden by the curve of the Earth. I'd need a tower a quarter mile tall, with bulbs on top. Unless I find a laboratory location with a nearby mountain, and I place my receiver shack at a few hundred feet elevation, up in the foothills with dirt roads. Yes, a distant lab way out in the boonies, with no industrial spies watching my every move, even no educated eyewitnesses. I'd pulse my transmitter, and watch the distant bank of bulbs through my binocs, and instantly I know the power level needed to trigger the receiver. Sweep my beam across the receiver, plot its sectional profile. Mr. Cisco, pack all the trunks, we're taking the next train to Pikes Peak. Oddly enough, 3 years before his 1899 lab, Tesla apparently was in Colorado Springs, even climbed up Pikes Peak. JPEG. And performed resonance experiments with portable radio equipment. Wow! I will note, however, that transmitting small amounts of energy over that distance isn't a challenge, as that's literally how radios work, sending and receiving low-frequency, low-energy photons. I hope this helps.
We can continue with Mike's answer.
In 1902, Tesla was attributed with claiming to have been sending wireless messages from Wardenclyffe for some time. However, this does not seem to be verified and probably isn't true. The patents for Wardenclyffe are available online and free, so presumably someone could have verified that it works, if only it did work, by now. US 1119732A, apparatus for transmitting electrical energy. Google patents. VNTBSLA. ABPARATUS for transmitting electrical energy. Application filed JANJB, 1902. Renewed May 4, 1907. 119,732. Patented December 1, 1914. Witness Inventor R. IG4TTORNEYS Nikola Tesla, or New York, NY. 1 apparatus for transmitting electrical energy. Specification of letters patent. Patented December 1. Application filed January 18, 1902. Serial No. 90,245. Renewed May 4, 1907. Serial No. 371,817. To all whom it may concern, be it known that I, Nikola Tesla, a citizen of the United States, residing in the borough of Manhattan, in the city, county, and state of New York, have invented certain new and useful improvements in apparatus for transmitting electrical energy, of which the following is a specification, reference being bad to the drawing, painting and forming a part of the same. In endeavoring to adapt currents or discharges of very high tension to various valuable uses, as the distribution of energy through wires from central plants to distant places of consumption, or the transmission of powerful disturbances to great distances, through the natural or non-artificial media, I have encountered difficulties in confining considerable amounts of electricity to conductors and preventing its leakage over their supports, or its escape into the ambient air, which always takes place when the electric surface density reaches a certain value. The intensity of the effect of a transmitting circuit with a free or elevated terminal is proportionate to the quantity of electricity displaced, which is determined by the product of the capacity of the circuit, the pressure, and the frequency of the currents employed. To produce an electrical movement of the required magnitude, it is desirable to charge the terminal as highly as possible, for while a great quantity of electricity may also be displaced by a large capacity charged to low pressure, there are disadvantages met with in many cases when the former is made too large. The chief of these are due to the fact that an increase of I more vigorously. Therefore, in order to y-tickable, the capacity entails a lowering of the frequency of the impulses or discharges and a diminution of the energy of vibration. This will be understood when it is borne in mind that a circuit with a large capacity behaves as a slack spring, whereas one with a small capacity acts like a stiff spring. Vibrating found it imperative to so construct the elevated conductoid that its outer surface, on to accomplish this result I have which the electrical charge chiefly accumulates, has Lt self a large radius of curvature, or is composed of separate elements which, irrespective of their own radius of curvature, are arranged in close proximity to each other and so, that the outside ideal surface enveloping them is of a large radius. Evidently, the smaller the radius of curvature the greater, for a given electric displacement, will be the surface density and, consequently, the lower the limiting pressure to which the terminal may. Q. Is there any proof Tesla actually transmitted energy 26 miles? Footnotes. 1. http://www.teslasociety.com/warden.htm.
What do you think? We will continue with Andrew McGregor's answer.
You can indeed transmit energy wirelessly. There's just one little problem. It is horrendously inefficient at any significant distance. If the sender and receiver are almost, but not quite, touching, like in a wireless phone charger, or a tap and pay credit card, then it can be efficient enough to be useful for low power applications. You'll note that you don't get wireless laptop chargers, which is because that is somewhat beyond the reasonable power requirement. So, if you were distributing energy as a business, would you generate 1000x as much energy as your competitor who uses wires, just to throw away 99.9% of it? No, you would not. It is completely economically infeasible.
The video is over. Thank you for staying until the end. Thank you for watching this video. If you like it more, you can subscribe and leave a like on this video. This is now the end of this video. Remember to leave a comment to tell us if these answers resonate with you. Bye and see you soon.